In a lot of the work that we do with limits, we look we have a tendency to look at the limits that are more difficult to calculate, the trickier ones. But for the most part, limits are really easy. If you're looking at a function that's doesn't have anything going wrong, so let's take the limit as x goes to 2 of 3x plus 7, right? Well, 3x plus 7 is just a line, got a y-intercept of 7 and a slope of 3, right? And if I'm saying, hey, what happens when x gets close to 2? Well, the value is going to be getting close to whatever that is up there, right? What's the y value? Well, notice that at x equals 2, 3 times 2 plus 7 equals 6 plus 7 is 13, right? So at 2, the function value is 13, and it's really pretty easy to say that this limit as x goes to 2 is going to be 13. If there's nothing there's nothing that's causing you to think something weird might be happening, then as x goes to this value, the function value is doing the same thing as just plugging the x in. We'll give a definition eventually in a calculus class of continuity, but from the pre-calculus side, it doesn't. I don't need to be too technical here. That if there's no problem with the function at this value, then it's easy enough to figure out the limit by just plugging it in, right? Here's another example. What's the limit as x goes to 4 of x squared minus 9? Well, x squared minus 9 is just a parabola that's shifted down 9, and I'm going to plug a 4 in here, and what's it at? I don't know. Well, 4 squared minus 9 is 16 minus 9 is 7. 7. The limit of x squared minus 9 as x goes to 4 is 7. It's that easy. The issues are going to come up when we're trying to divide by 0, or we're trying to there's other things that we run into where you're trying to do something like 0 raised to the 0 power or something like that. I mean, that's not till we get to calculus, but limits, just what's the y value doing as x is getting close to this thing? If the function's a nice function, just plug the thing in, plug the x value in, see what you get. That's what the limit is.